Welcome to our May event. Very exciting. My name is Nikki Rubenstein, and I'm on the R-Ladies Melbourne Organising Committee. So I wanted to start with, as we've already mentioned, today is Women in Mathematics Day. So happy Women in Mathematics Day. And the goal of the day is to inspire women everywhere to celebrate their achievements in maths and to encourage an open, welcoming and inclusive work environment for everyone. So very strongly aligned with what R-Ladies stands for. So we thought it would be fitting that we have a meetup on the same day. Just to give you a bit more detail, so why May 12th? On the slide is a photo of Maria Mirzakhani, who was born on May 12th, 1977. So it's for her birthday. And she was an Iranian mathematician and a professor of maths at Stanford University. She was one of the world's leading experts in geometry and dynamical systems, but she died tragically from cancer in 2017. She was only 40 at that point. She didn't give many interviews, but in the few that she did give, she spoke very eloquently about the beauty of maths and her joy in doing maths. And so that's how we have Women in Mathematics Day today. So happy Women in Mathematics Day. And if you follow Twitter, there will be a video being shared there. So I encourage you to go check it out. In other news, R-Ladies Melbourne had our AGM last month. On this slide, we have our committee members for 2020. Big thank you to the 2019 committee members for the fantastic work that was done, and a huge shout out to Sepida for her tireless efforts as president. A few call outs here. So for 2020, we have Surish taking up the presidency, Marie as vice president, Adele has agreed to stay on as treasurer, and Shazia has taken on the role of secretary. So that's us, and you should keep in contact with us, especially if this is your first R-Ladies meetup. Welcome and keep in contact. We are active on many different channels, as you can see here, so pick the one that is best for you, or pick all of them, but be sure to keep in touch. And then I just wanted to have a call out to the fact that the times are changing at the moment. So we would normally have a monthly in-person meetup, which is obviously not possible right now. So we are transitioning to online meetups using Zoom. So this is a newish experience for us. If you have feedback on the sessions, please let us know. But just some etiquette around the session. So please use the chat if you have questions, and we'll read them out at the end. Please make sure that during the presentation you stay on mute so that we don't get any background noise interfering with the presentations. At the end of the session, we will move into breakout rooms. So one of the things that we have in our meetups is time for socializing and networking, which is a bit harder to do on a virtual meetup, but we're going to try and do it with breakout rooms. So you'll be assigned to a breakout room with a few other people to meet some other members of R-Ladies. And just to let you know that this session will be recorded. A thank you to all of our sponsors. And now moving on to the main event, I'd like to introduce you to this evening's speaker, Virginia Liu. Virginia is a self-taught programmer and UX designer. She has a Bachelor of Medical Sciences, a PhD in psychology, and is now working as a postdoctoral researcher in the Optometry and Vision Sciences department at the University of Melbourne. As part of her work in the Vision Sciences, Virginia has co-created the Binovisualfields R package and went through the arduous process of getting it on CRAN. So she's here to tell us more about this experience. So I'll hand over to her now.
Thank you for the introduction, Nikki, and thanks for being here. Good afternoon, everyone. It's a great pleasure to be here to share some of my experience developing the R package. So before the talk, I'd like to say a little bit about myself. So I had 0 programming skills before my PhD, and I taught myself 3 languages during the PhD, and have been working in multidisciplinary teams since then. So I just want to say to anyone here new to programming, you can totally do it. Just have confidence in yourself. Just take the leap and start your project. So you will definitely get there. Okay, so my talk. So I'll divide today's talk into 2 parts. In the first part, I'll focus on the background knowledge related to visual-field test. In the second part, I'll cover some of the information relevant to writing your own R package in the correct structure and format, so CRAN will accept it. Okay, so the background part, what is a visual-field test? It's a test routinely used in optometry clinics. So the 3 machines in the picture you are seeing now are all visual-field machines. I like to say that optometry and vision science is a perfect background for anyone interested in working in the interdisciplinary field of medical science and technology. There are a lot of imaging equipment that are part of routine eye exams, and this is the broader context where the whole visual field research is from. So visual field tests are used for the diagnosis purpose for many visual and neurological disorders. Glaucoma is one of such diseases. Our Bino package was mainly developed for simulation of binocular visual fields for glaucoma. Glaucoma is a medical condition where visual neurons in the retina die. What you are seeing in this image is a retina at the back of the eye. There are millions of tiny visual neurons covering the whole retina. In glaucoma, for various reasons, these visual neurons gradually lose their function and eventually die. For any patients with glaucoma, the loss of visual neurons can start anywhere in the retina and is usually limited to small areas. For those of you not from a medical background, generally speaking, neurons do not regenerate. So once they die, the function is lost forever. This means once a patient has lost some parts of their vision, the patient will never get that back. The challenge of diagnosing glaucoma early is that there are no subjective symptoms, no pain, no any form of discomfort in the eye. So until binocular vision loss occurs, there is no subjective noticeable visual impairment either. So how can clinicians diagnose glaucoma at its early stages? So that's where the visual field test comes in. It can tell clinician where in the patient's retina visual neurons are died or are dying. So how does it do it? So for those of you unfamiliar with the anatomy of the eye, here's an eyeball from a top view. On the right side, maybe here, this is the back of the eyeball where the retina made of million tiny visual neurons is. There is a topographic correspondence between spatial locations in our field of view and the visual neurons in the retina, such that neurons at location A here respond to light from location A in the world. So knowing this, we can present a light spot at location A to a patient. And if the patient can see the light at the location A, we know that we can infer that the neurons at location A in the retina are probably working okay. And that's the rationale of doing visual field test. So in clinical practice, we only measure visual field binocularly. Binocular means that a patient will do the task with one eye open, with the other one covered by an eye mask. In contrast, binocular viewing means that the 2 eyes open and view simultaneously. So during a binocular visual field, some dots of light are presented at the back of this machine. This is another machine, visual field machine. So people will need to respond with a button pushing to indicate whether they see a light or not. So the light, dots of light are presented one after another with their spatial locations vary in a random order. About like 50 to 70 locations can be tested in one run. There are the more test locations, the longer a test will run. As you can imagine, we can only concentrate on kind of attention demanding tasks for a limited time. So per visit, there are only a limited number of visual field tests a patient can perform. And that's, so if we want to know binocular visual field status, it makes sense to simulate binocular ones from monocular results rather than doing separate tests. Here are some examples of monocular visual field printout. This is how the results of visual field tests are usually presented. So these are kind of color-coded monocular visual field examples. So all of the visual field machines present results roughly in the similar format. So here, if you see 0, it means that there is no light sensitivity whatsoever. And 30 means super high light sensitivity, so healthy retina, corresponding retina. In the top row, this is a pair of a healthy visual field results. On the left bottom corner, the left eye here is healthy, but for the right eye, there's a top left corner is impaired. So we usually call it a superior nasal defect. And on the top to bottom, this pair basically shows bilateral. So in both sides, the superior nasal side, quarter is impaired. So the question is, how can we calculate binocular visual fields from these monocular ones? So here is a schematic representation of the viewing angle when the monocular visual field test is taken. So the person is looking straight ahead. The fovea, which is the center of our most sensitive part of our retina, is aligned with the center of the visual field machine, also the test pattern. So when we view something binocularly, the eyes have to converge, and this is how, from the monocular viewing angle, the two eyes converge to at a certain distance, and that's how we can see things clearly in focus. So in this process, there is another important variable, that is the depth. Once your eyes are focusing on an object at a particular distance, in this case, location P, let's say, objects on the same plane as P are in focus, but you can still perceive objects out of focus, such as objects at location R. So blurry as they may be, you can still see them. And this location, it can be closer to the fixation distance or can be further away. So in reality, objects out of the current focus can be of great importance for our functioning. Here, an example, if we drive towards an intersection, when you are far away, you're focusing at the distance of traffic light, you see green lights, so you keep driving. But by the time you will come close to the intersection, you're more likely to still be focusing on traffic in front of you way beyond the intersection. But you still need to monitor the lights just in case it can change, and then you have to apply brake. So objects autofocus are still important for our survival. So the second reason to simulate binocular visual field rather than testing binocular field, it is that it's totally impractical to test the multiple fixation distance and object distance to incorporate the depth information. So now the question is, given some binocular visual field examples, how do we calculate the binocular ones incorporating the depth variable? Luckily, we know the trigonometry needed to simulate the binocular visual fields with all the variables discussed previously. And people actually have known this for decades, yet there had been no tool for researchers and clinicians in the field to do this easily. That's why we made the effort to make the binocular visual field package. So to give you an example, this is again with the, oh, sorry. So in this scenario, in the previous driving scenario, for a person with a bilateral superior nasal defect, where in the corner, both corners, if they have visual field impairment, you can see that their binocular visual field impairment would cover a much broader area when the object distance is much closer than the fixation distance. It is possible that such patients may not notice traffic light change in this scenario, as we would normally do. Okay, so here are the links to the online version of the package. And if everyone want to open it and have a play with it, I'll go through it with you guys. Well, the package you can download from CRAN or from our the link below in my presentation. The Shiny app is actually live online. There are two tabs. If you see, look at the top of the tab, there is a binocular vision in 3D and then binocular vision simulated using the 12 archetypes. Let's just focus on the first tab first. On the left side, usually we would choose a fixation distance from the bottom slider first. In daily life, we usually focus on something about 62 centimeters away. So maybe you can choose like, this is in millimeters, so it's 640 millimeters, something like that. And on the right side, there are 12 binocular visual field archetypes. You can just randomly select any one of them. And then it won't, only the left binocular visual fields on the, next, below that, how do you say it? Below the choice button, like it's changed. If you change two different archetypes, the rest of the interface will not change. So now if you similarly choose an archetype for the right eye, it will still not update. So only if you push the blue button select below the two binocular fields in the center, kind of in the middle of the page. And if you push the select button, it should update the binocular ones based on the selection of the two visual fields. Just bear in mind that this is internet. Sometimes it's relatively slow. So I was pushing the select button multiple times and kept updating. So maybe you just push once and it should work. Can you see that the binocular fields actually updated depending on your choice of the binocular ones? And at this time, you can drag the object distance sliding bar on the left side, and the binocular field would also update. So given different combinations of fixation distance and object distance, the results of the binocular fields change. So that's a point of giving a interaction, interactive user face. If we now switch to the second type, this is when your clinicians want to compare the binocular visual field simulated at fixation distance versus a object distance closer than the fixation distance, and another one representative of beyond the fixation distance. They want to compare it at the same time. So we use the same kind of relative design, but in this case, you can choose any archetypes for left and the right eye, and then simultaneously choose 3 representative distance and see comparing the change of binocular visual fields across the 3 distances. Yes, so that's it about the demo of the Shiny app online. Does anyone have any questions at this point? Oh, no? Okay.
I have one, and I was just wondering, like, do clinicians maybe that you work with use it, or like have you shown it to them? And I don't know, what's the sort of like take on using this?
So our group people, of course, we have been using it. There are collaborators of our lab actually are interested in looking at how patients with glaucoma actually reach objects in their daily life, like a cup of tea. Will they actually knock it off because they couldn't see it somewhere? So they are actually doing experiments using the simulation results to predict
Cool.
how their behavior will go. But it's I'm waiting to know the results. Yeah.
Yeah, awesome.
Okay, so the R package development. Of course, the environment is R and R Studio. Here are a list of resources I actually used during my development. So I just, I think these R package, Hadley, the New Zealand computer science professor, his book is very useful. I actually didn't use much of the manual. That book basically covers 99% of the information you need to know. So before talking about development, I think most people, if you haven't actually done one, it's worth of knowing what R package is and why you actually want to write your own package and publish it on CRAN. It's much easier if you just write all your functions in a script and source it from whatever experiment script or other analysis script without writing an R package. Yeah, so basically judge what is your purpose and make a decision whether you actually need to write a package at all. So R package is an extension of the R-based system with code, data, and documentation in standardized format. It's not just a list or a collection of R functions. The data and documentation to show other people is the essential part, and actually the most kind of challenging part I experienced during the development stage. So also it's worth of kind of, you need to know that there is a life cycle of R package development. The source folder that you kind of code yourself, and then the bundled format, binary format, in-stored format, and then you when you call the library, it's kind of in the memory, because different formats are used for different purposes. After a year finishing programming the package, just before I submitted to CRAN, there was like a long gap, and I totally forgot which format I should be using to actually do the CRAN check. I was using the wrong format and kept getting errors. So it's really important to know which format is for what purpose and what you can do with it. So here is an example of a typical basic structure of a package at the development stage. So this is the folder structure. Usually, once you create a project, the R folder is given by default, and the namespace and description files are given by default. I think you write your own vignette, test, and other folders, just depending on your purpose. And so in the structure, this is the structure of the R source folder is very different from the installed package structure. By comparison, I'm just giving you an example. For example, my package, once installed, actually have all these folder structures with an HTML, with a help, and the Shiny demo actually was brought up one folder and is showing itself with the actual data folder and the R data and the description and namespace file still there. So here is my R folder with all the functions in my package in the development folder. Again, this is an example of how it looks like when it's installed. And here is a summary that how the files and the folders in the development stage folder actually change structure to the bundle, to the binary folders, and it's worth of having a clear mental model how it works. And there are certain functions actually, for example, the build and reload, you usually use it quite often when you change your functions and then reload and then test how it works. And then there are other functions depending, anyway, you purpose. And these are the standard packages essential for writing your own package. And you have to reinstall these before starting. Okay, so the details are all included in these slides later on. I will not cover the whole crash course actually given when I was writing these slides. I'll just talk a little bit about the challenges I didn't expect during the development. The first one is the writing the test folder, unit tests. If you are a software engineer, you definitely would have done this as, you do this as a regular part of your job. But for people like a researcher, we don't really do this unless we actually have to make the package public. So I actually only did the unit test and learned everything related to it for the first time during the development of this package. If you are just doing unit test on some calculation algorithm, it's relatively easy. The graphic output of function, how you actually test they work properly, was quite challenging, especially I think this second package was good for ggplot figures, but we only use the base figure plot functions. I end up, because of the Shiny app actually works, I end up just skipping the whole thing. If anyone actually are going to do this part, please let me know. I really want to learn together with you guys. And another small challenge here is that getting the environment variables included in the package. There are three types of data you can include it in a package. One is the essential package. So you can, by calling the data function, you can actually upload. You can, you can upload the, you can call the data in the memory. You can use it. For example, like in the diamond package, there is a diamond data set. The other one is that the external extra data that you can actually put in any format, like in Excel or anything in, and put in the instance folder. But sometimes you actually want the certain constant values to be made available when people actually call the library itself. And I really wasn't aware this the convention that you actually need to write is a R file, and putting this function there, basically just naming your constant variable there, and it will actually be made available. There are certain challenges when I encountered when uploading it to CRAN. One is this description file. For certain reasons, I submitted 3 times, and twice, the first 2 times, the maintainer both times asked me to write something here in the reference when I have already given the citation file in my folder. Apparently this is required, and for as much as I have done my research reading the R package online book, I actually couldn't find anything related to giving the reference in the description file. Here is another point out by the maintainer who checked my package. Just for everyone, interest. If you are changing the default parameter, for example, here I'm changing the graphic parameter, you actually have to put the on exit to change back to the old parameter immediately. Usually we only put it at the end of the function or the script. This is not acceptable if you are submitting it to CRAN. And then the last, I think it's a category of challenge when you design a package for other users. It's just the design thinking what the new users would do. And one we didn't expect is the speed issue. So the Shiny app, if you download the package and open up in your own browser, it's totally fine. But once we put it on the website, the calculation, because there is a huge array calculation every single time you change the fixation distance, it's really slow. But as you all know, the website, if the website doesn't respond like promptly, people will just think that the website doesn't work and will just leave it, and you lose your user forever. So the speed issue is kind of essential. So we actually changed the calculation in the Shiny package up on the server so that the reaction speed was acceptable. But for the clarity of the code, and just in case people would actually download it and then use the Shiny app themselves and then check in their own data, we decided not to change the code in the R package for the clarity of the code itself. That's some kind of a design issue we ran into. Okay, so the rest is just the for your own information, you can go through all the details about writing each file and folder to hopefully to make a package that is CRAN compatible. That's it. Thank you so much, everyone.
Thank you
Thank
so
you so
much,
much.
Virginia. Such an interesting talk. Do we have any questions?
I'll just.
I have one. I could ask one. In terms of the next plans, do you plan to add an extension, or how do you plan to improve on it?
That's another design issue. So if you in the other, so I have two links. One is to the Shiny app. The other is my supervisor's webpage. There are multiple R packages and softwares related to visual field test. So we were planning actually to put my package together, incorporate into the other visual field package. But then the kind of the design issue, again, the user interface wasn't so consistent and it would be very confusing for end user. So we decided to separate it. This is already an extension of another existing R package.
Thanks for the response.
Thank you.
I have a question as well, because I mean, I know as you mentioned, one of the big challenges when you write a package or any module in any language is to write testing so that your code is like safe and any change. And I was wondering if you had, I mean, I'm starting to do that now. I'm not a software developer, no background in computer science, but I'm from a stats background. And I was wondering if you have any suggestion about how you approach them, or like what you found useful and sort of like ideas around that.
So the functions, like it's actually just testing whether, so you run a function given your input and the output, whether it's identical to whatever, whether it's a number is equal to or identical, it's a string output or other format of output. Relatively, that is straightforward using the test that package. I think there are quite a few packages doing similar things. So I went through all of them, just Googled everything. And in the end, I just used the test that package. I think you might want to have a look at them and see which one actually fits your purpose better. Yeah.
Thank you.
Do we have any other questions?
Can I ask just like kind of a conceptual question? I was just wondering how do you decide when in our package you need to develop an R package versus a Shiny, like, and maybe why did you decide to do both, or just kind of conceptual, I guess.
One, so the Shiny, including a Shiny app, is actually my idea. So at the beginning, my supervisors was only asking me to do the package, and no one was aware that Shiny was available and is capable of doing what we intended to do at that stage. So of course, I've been coming to R-Lady meetups and other programming groups. So I was aware of Shiny and the D3, the both visualization tools, because the other visual field package was already in R. Everything was done in R. So we decided to go with R. And of course, we included Shiny. And actually, after I successfully made it work for this package, the visual field package, the other one is kind of switching to Shiny 2 as a kind of UI to control the visual field machines. They're actually working on that. I don't know how it's going, but yeah, it's getting popular.
Yeah, definitely. It was very, very cool. Congrats,
Yeah.
well done.
Relatively really easy. It doesn't take too much time to make one work. Yes.
Thank you.
My pleasure.
I have a question. So I feel like you probably did a pretty good job of answering this, but I'm going to ask anyway. If you had your time again, and so you were starting your package development from the very beginning, what is the one thing that would make it easier to transition it to CRAN afterwards? Or they're just too many finicky things that maybe there isn't one?
Actually, it took us maybe a year and a half to get the package up to CRAN, but the development time was only half of that. We were waiting for the paper to be published so we can put the reference in the package. That took half a year. If you get your paper published faster, you can get it on CRAN faster. It's not that it's for reference, for people to cite your package. It's actually, I think from my conversation with people in the field, if you don't give a reference, people would actually not trust your package and what it does. So giving the reference, the publication that has been accepted means that people in the field recognize what you are doing is correct, and they will actually download it and use it. Yeah,
okay, that sounds like good advice. Any other questions?
I just had a general question regarding who are you working with? Andrew Turpin, is he your supervisor?
Yeah, so he's the professor from the computing side, and the other one is Alison McKendrick. She's the head of the optometry and vision science.
Cool.
That's why we're working on so many programming projects.
Yeah, that's what I was wondering, yeah. I could see Andrew Turpin, so that's what made me think that probably that's where it is coming from.
Yes, and we did a robot project before, and it was super fun. There was a robot, the Now robot. The whole robot thing is from the computing department.
Yeah, that is actually pretty cool.
Thank you so much, Virginia, for sharing that talk with us.